Hello, my name is Akimi and I'm a software engineer in California. I love technology and I am also very passionate about spoken languages. Today, I'd like to introduce one of my dream projects. It is a multilingual peer-to-peer video chat app. So before we talk about what it is, I'd like to start with why I wanted to build this application. There are a lot of video chat apps today, such as Zoom, Google Meet, and Skype, and they all play an important role in connecting with people remotely. As a passionist of languages, I am very excited to meet and connect with people who do not necessarily speak the languages I can speak. When I meet with someone online and I do not fully understand the languages they speak, I wish I could know what exactly they're saying in my preferred languages in real time. I felt that would help us to connect more deeply with people whose preferred language is different from ours. So, I made this application. I'd like to briefly go over the technologies I used for this application. For the front end, I chose React for my front-end web framework. I used Mapbox and Leaflet to create the world map interface. I used Material UI for UI components. And finally, I used Google Firebase to host the static content and also get a hosting URL. For the animated avatars, I used Adobe Photoshop and Illustrator to make the avatars. I learned them from scratch for this project to make my own original avatars because I thought they were very cute. And for the speech to text and translation, everything was built using the Microsoft Azure platform. In particular, I used the Azure Speech Services JavaScript SDK to communicate with their speech-to-text API. And I deployed an Azure Cloud function to generate the token to authenticate with the speech-to-text API. Finally, for the peer-to-peer communication, I implemented the WebRTC protocol to enable a truly peer-to-peer communication. I used the Google Firestore database and its real-time updates feature to establish the communication between two peers. In total, it may seem like a lot of technologies are involved, but the most crucial technology for this application is the WebRTC protocol. So I'd like to deep dive into it right now. First of all, what is WebRTC? It is a way to enable peer-to-peer communications. Peer-to-peer means that users are directly communicating with each other instead of going through a server. WebRTC is a protocol supported on most modern browsers. It has APIs to simplify features such as sending videos, audio, and text data between peers. The most challenging aspect of WebRTC is the setup phase, also known as negotiation. This is when we establish the connection between two peers for the first time. You still need a central server to handle this step. This is where Google Firestore comes in. Google Firestore is a NoSQL database that is part of Google's Firebase platform. The reason I chose Firestore was because it has real-time updates feature, which allows for two-way communication between the user and the server. Typically, web apps only use the HTTP protocol, where clients send a request and the server sends a response. But with the real-time updates, we can receive server-side events from Firestore when the database changes. This enables us to successfully complete the handshake to connect two peers. This feature is available in Firestore API through onSnapshot method. Implementing the WebRTC negotiation. As shown in this diagram, the WebRTC negotiation has several steps, each of which could fail at any point. This is why the setup phase can be very complicated, and we need to handle failures very well. Thankfully, there are a lot of good resources regarding this, and in particular, I learned a lot from these two well-written articles by Mozilla about how to build the perfect WebRTC negotiation. So let's move on to the code type. The code is divided into two parts, the server and the client. The server directly hosts the Azure Cloud Function app that generates the authentication token to communicate with the Azure Speech-to-Text API. The index.js file defines the cloud function. I store the configuration information such as the API endpoint and region into configuration file called speechconfig.js. Import it up here and use it in the rest of the code. I also cast the token result up here to reduce the number of API requests. The client directory holds the React app that is run on the client side. The public directly holds all of my assets, and the source directly has the source code for my React app. I have a context directory where I created components related to the React Context API. I use the Context API for storing some global states. The most important one is for the Firestore database, and you can see me set up the database connection and store it into the state object here. For this app, I followed the React functional component model where everything holds a functional structure. Here I have components for each UI module, such as the chat page and the map page. Let's take a look into the chat component. The chat component represents the chat interface. Because of that, it also has a lot of logic related to WebRTC. You will notice that I have some variables in the global state for the WebRTC. This had to be put up there because WebRTC has its own life cycle that is different from the React's life cycle. As mentioned earlier, WebRTC negotiation is very complicated and has very many steps, but I do want to highlight one thing, and it is the onSnapshot method. Firebase provides the onSnapshot method, which enables the client to listen to real-time updates from the database. You will see that I use it in several places. And this is the most important feature for the WebRTC negotiation, because in order for the negotiation to succeed in the central service needs to send updates to the peers. This part is hard to cover in a quick demo, but as mentioned before, the full details are covered in the really good article provided by Mozilla. So thank you so much for listening and watching, and bye bye. One more thing, if you are interested in my project, the website is up and running at this link. And if you're interested in watching the video of the demo, the video is up and running at this link. And also the source code is available at this link. And all the links are available at the description below, and check them out. Thank you.